Hello, I'm Brian Robison, Senior Director of Product Marketing and Chief Evangelist at BlackBerry, and I'm coming to you today from my farm in northern Kentucky. Over the past few months, we have seen a literal explosion in cyber attacks focused at us at home rather than our offices. I plan on giving you a glimpse into the mind of the adversary in today's Hacking Exposed, Learning from the Adversary, a look inside the techniques of Ocean Lotus, also known as APT32. The goal of this session is to show how you can reproduce these methods in your own environment to not only test your defenses, but also your people. We all know that hacking a human is easier than hacking a computer, and Ocean Lotus is very effective at hacking humans. The attacks I'm going to talk about today are considered fileless attacks. Let's begin by exploring why fileless attacks matter. A Ponemon Institute study found that of the respondents, 54% of them have experienced a breach of some kind. Of those, 77% were found to use fileless techniques. Now, this study was done back in 2017, and since then, these numbers have risen significantly. Currently, we are seeing a huge increase in the quantity and effectiveness of fileless attacks, and over the past few years, we have seen a decrease in the use of executable malware being the cause of a breach. Now let's define and examine the attributes of a fileless attack. Fileless attacks are generally attacks that do not generate files on disk, thusly triggering a traditional AV scan. They do, however, need some place to execute code and establish some persistence. Usually, fileless attacks start with some sort of scripting code that will execute directly into memory and may even exploit that memory using a vulnerability. However, a fileless attack is usually not a file-free attack. Fileless attack is sort of a misnomer in this situation, as most of these attacks begin with a weaponized attachment, which is a file. But the files are not the traditional executable type of code, like an exe or DLL malware file, at least not in the first few phases of the attack. They don't write files to disk. This is the best way to avoid AV detection, is to not trigger a scan. These methods are most commonly found in the initial phases of an attack. Usually, the fileless portion of the attack is at the vanguard of the breach. Once in and connectivity is established, the attacker will usually utilize already existing and trusted tools to continue the attack in a method known as living off the land. Again, using tools that already are installed and trusted is a great method to bypass traditional security. No new EXEs are needed to further the attack. Sometimes, but less than one would think, a true zero-day vulnerability is found that the attacker exploits to their advantage. Again, it is far easier to attack the human and get them to run your code for you than to exploit software. So, how do these attacks begin? The first step begins with the user receiving an email laden with great social engineering, convincing them that the attachment is important and safe to open. They open the attachment. Then the critical pivot point, the application warning. Most systems and applications have decided to pass the buck to the end user when an action could cause harm. I feel that this is a scapegoat technique. Rather than building smarter software, they're simply putting the end user completely in the driver's seat when it comes to potentially running something that can take out the entire company. In any case, whether through some divinely inspired social engineering, maybe even extortion or guilt, the user ignores the software warning and clicks on the OK or Continue button. Game over. Now the embedded script runs, which may not be malicious yet, but usually the goal is to establish command and control over the endpoint, also known as C2. Once this is up and running, the system is now compromised and can be used to move laterally or even deploy some nasty ransomware that'll take out this system and everything else in the network. Enough theory and presentation. It's time to go back into the lab and demonstrate how these attacks are built and operate. Let's head inside. So, let's go into our macro. And what you're going to see here is that this is a very innocent macro. Again, all it's going to do is it's going to update the fields that are in the document. Now, this next attack, we're actually going to create a macro-based attack. So we're going to want to delete this innocent macro. And strangely enough, we're going to replace it with a macro that is just as innocent. Oop. Okay. This macro is technically just as innocent. There really isn't anything in this macro that is going to trigger any sort of security product. This is something really, really bad. Basically, what they're doing is they built a very innocent looking macro, essentially to bypass anything looking for strings or patterns that would potentially be malicious. There's no URLs or anything else in this document that's not in a comment code anyway, that could be picked up on. The reason that they did that and how they bypassed a lot of the security that was out there today is that they base 64 encoded the strings that have actually the bad commands in them, and they actually built in a base 64 decoder. In fact, this is an open source decoder. It's been around for a very long time, and they just cut and pasted it directly into this document. And I've made no changes to this part of the code, so it's just as it is. And again, like I said, it's completely cross-platform, meaning if it's a Mac, it's going to execute a Mac command. If it's a PC, it's going to execute a PC command. Now, where does it get these commands? Well, it gets these commands from the comments field and the company field in the document itself. That'll make a little bit more sense when I show you how those are actually edited. The great thing is that we're actually completely done weaponizing this document at this point. So we're going to go ahead and close our macros. And then we're going to save our document as a different document. And the reason we're going to do that is so that we can get the yellow box back again to control whether or not we want to actually execute those macros. Okay, so we've got our new document, but it's not weaponized yet. It just has the macro VB script in it, but it does not actually contain any weaponization. We haven't told it where to get the Trevor client. We haven't told it what to execute, etc. So we're going to do that now. As you remember from the macro, we need to do this in a base 64 encoded format. So what I've got here is I've got some to pre-create these to make it a little bit easier to use. We're going to take this PowerShell command here, put this into a tool called CyberChef. So we're going to simply paste in our command. And remember, we have to point it to the URL of this little simple web server running here in the bottom left-hand corner. So that's pretty easy. We just type this in. And again, we're going to download the PS1 and execute it directly into memory. Now, it's really easy with CyberChef to create a base 64 encoded format. You basically just paste your text in, you go over here and you grab the to base 64 and you drag and drop it here, and all of a sudden your text is now in a base 64 encoded format. So we grab this text down here, we copy it into our memory, and we're going to place it into the document. Now remember, from the VB code, these are placed into different fields, and where those fields are is in the metadata of the document. So we come in here to the document properties and go to the details. Now, the PC code is placed in the company field of the document, so you just paste that base 64 encoded blob of text directly into that field and hit OK. So on the Mac side, it's a little bit different. We've actually got to create a Python browser essentially to do our connection. So that's what this code is for. Essentially, it's going to create a Python browser. And again, just like we did on the PowerShell script, we have to put in our URL. And on the Mac, we're going to execute the Python client. Okay, so Now that we have the weaponized URL in, we're going to convert that to base 64. So we get this big blob of text. And this wrapper essentially is its own base 64 decoder again, but this time where we have our blah text, we actually have to take our URL, or our browser essentially that we built in Python, and we put that into the blah text there. We need this entire command encoded into base 64, giving us this great big block of text here. Now, just like we did with the PowerShell command, we're going to take this block of text and we're going to paste it and put it into our document properties, into the comments field. And now the document has been weaponized for both PC and Mac. So let's open our document. And when this runs, hopefully here within a few seconds, if we didn't do any typos or anything, we will see the traditional connection over here on the left. And sure enough, we do see that we have a new connection. We can now interact with that session, and we can do the same things like we did before. We can kill Microsoft Word on the right, just like that. Now, as I promised earlier, we're going to take a look at this on a cross-platform system. So I actually happen to have a Mac box, and here's my resume that I had on that file share. And to recreate this attack in its entirety, this machine is running Office 2011, just like the original attack. We're going to open up our resume, enable macros. And hopefully, if everything went well, we're going to see the hit of the web server, as well as the connection of the command and control client on the attackers over here. And yep, sure enough, you can see we did actually get the download of the Python client this time, and we have interaction with the server. So we can actually take a look. We can now interact with session 1, and we can now issue Windows commands, or and we can now issue Linux commands or BSD commands for the Mac system. Okay, so now that we can actually issue commands, one of the interesting things I want to try to do is I want to try to extract the iTunes or iCloud password from the user on the Mac. So let's bounce back over here, and I have this command already written. Let's grab it. And this is basically going to prompt the user to enter their iTunes password, which for Mac users happens a lot. And we're actually going to tell the application iTunes to do this. So what we're going to see is we're actually going to see the iTunes application launch on the Mac over here when we enter this command. So let's go ahead and send it. And you'll see over here, just like every day on a Mac, you get asked for your password. So the iTunes application starts bouncing. We click on it, and it asks us to verify your iTunes password. And it's got the right icon and error message and everything. So you go ahead and enter your password in. And you click sign in. And over here on the command and control, the command that gets entered, the returns comes back, and it actually says, this is my password. So there you go. This is a weaponized document that you can use to extract somebody's iCloud password or whatever from a Mac. And in this demonstration, we showed how easy it was to essentially attack both a PC and a Mac with the exact same document.